I've been known to rant occasionally. I'm going to try not to do it this time, but I am going to try and play the devil's advocate on this talk. Try and present some extreme views, not to give you any useful information, but just to sort of make you A, hate me, and B, through that hate, try and change the way you behave. Like many people, I started out my career at university. I started a computer science degree when I was a teenager. So this meant when I started university, I knew absolutely everything. So when my first assignment came out, within an hour I'd submitted it. I knew I was going to get 100% because I knew everything. I'm a teenager. What could I possibly learn here? Now, back in those days, I feel really old having to say that, but our assignments got printed out on a dot matrix printer, the ones with the cool little tear-off things that you could then turn into springs. Who did that? Yeah, one person. And it had all these strange red marks all over it. It had a couple of comments that made no sense to me. One was, you didn't have enough comments. It was not that my comments that I had weren't good enough, it's that I didn't meet some magical number of comments that was in the tutor's head, and I lost marks. Now, the other one I hit was, your variable names aren't good enough. Again, strange comments. Now, I wasn't 100% sure what this meant, so my next assignment looked like your average Java program. It had more comments than code, and every variable name was about 80 characters long. Now, I feel a lot of people have gone through this same experience, and we're sort of, as an industry, sort of turning into this story that goes around the internet every now and again of some scientists. It's probably not true because I'm sure that they would have got sued or something like that, but some scientists that put some monkeys in a cage. They put monkeys in a cage with a banana, and now any time a monkey went to grab that banana, they'd electrocute every single one of the other monkeys. Eventually, what would happen is the monkey would go to grab the banana, and all the other monkeys would beat up that monkey. Now, they'd keep this going, and a few generations go by, and a few generations of monkeys, and now no matter how many monkeys they put in there, they goes to grab the banana, all the other monkeys will beat them up. Now, the strange thing is, so many generations have gone by that no one knows why they're beating up this monkey. It's just something that they have to do. And I feel that we as an industry have reached this way with comments. Comments are just something that you have to put into your code base. We don't really think about why. We tell our junior programmers, you must comment code bases. In our coding conventions, you must put comments on every function block. We end up with comments like this. I know you laugh, and I know you think it's a contrived example, but is this much better? Apparently, the Johnny 5 code base feels that this is necessary to comment, but not this. So this means that comments become distracting. Comments are things that we don't read because they're useless. They don't give us any information. And I think the biggest example of this is Sublime Text 2. Its default theme is black. And what color are the comments? They're gray. This means that it says to me, whoever wrote that theme says, comments aren't important. I want the code to stand out, not the comments. And I find that comments also make us lazy. They become a crutch that we can use, and an excuse that we can use to not refactor and not make good code. So we get complex code, but it's OK. We've got a comment, so we can ignore that complex code. But this is not true, because complex code hides bugs. So why not take the time to fix that rather than write a comment? This is an actual example that I pulled out of some Adobe software. Just I went looking. It wasn't hard to find an example. The comment gives us some information. Now, the problem is that they've used the comment to add information to the code. So the piece of information that cannot be grouped is only present in that comment. I can't test a comment. I don't know if anyone's written a natural language processor recently, but it's hard. Impossible, nearly. And the other thing is, you can't share comments. Sure, you can copy and paste them, but the last time I saw people copying and pasting code, I ended up with comments that said, returns true, and the whole thing returned false. So let's not do that anymore. So instead of putting the comment in to add that information, why not just refactor it? so that it looks much clearer. We've got a function now can be grouped. It's free factored, so it's just doing one thing. Now we've got functions doing just one thing. And we use compose to give you back that convenience function. It's no comments, and I would argue that it's probably it's easier to read because it tells you exactly what it's doing. So I want to propose that instead of telling junior developers that we should add comments to our code, let's ban comments from our code bases and see what happens. I find, in my experience, there's a relationship between comments in code and how bad the code base is. The more comments you have in your code base, I can promise you that that code base is going to be worse than a code base with less. Now, every good rule has exceptions. And I think one great example of comments that I've seen in my career is inside the jQuery codebase. If you read the jQuery codebase at any point in time, and if you're a web developer, I highly recommend that you do. It's pretty easy to read. They've recently split it out into modules so you can read important parts. But what they do, because they're building on such hostile platforms, they're building on top of IE6, for example. Every time that they have to put a workaround, and every time you put a workaround for IE6, it never makes sense. So what they do is they put //support IE6, list what the bug is. If there's a bug that they've filed, they'll link to the bug so you can track the progress, and then they'll put the code in. That's about one of the best examples of comments that I can have seen. The astute of you out there might be saying, but Jared, I use to-dos in my code. Stop it. I did some searching. This is actually something I hit. So I imported a C++ library. I didn't have access to the source at that point in time. I called the function. The window didn't close. Batted my head against the wall for a day. I finally requested access to the source code, and that's what I found. Now, the problem is that you put it to do it and you forget about it. It's not able to be searched. It's not able to be prioritized. It's not in your backlog. So every time you want to put it to doing, put it in the backlog. And you might be thinking, well, I don't have that many to-dos in my code base. I did a search of 25 billion lines of code in various open source projects, the Linux kernel, MySQL, things like that. There were 5 million lines of code that reference to do, fix me, or hack. That's 5 million lines of code that can't be fixed, can't be easily searched, because it's in the code base. Now, naming. Everybody says you've got to name your variables well, it's got to be big in English, and that's why we get Java. We get abstract, concrete, factory, path, strings. Go search for them, they're huge, they're like 80 characters long. Anyway. But is readability the right thing to be striving for in a code base? Some scientists asked this question, and so they hooked up various programmers of various skill levels to some eye tracking software and asked them to read code and find out what that code executed. So this first video I'm going to show you is one of those. This programmer has 10 years of experience, and he's asked to read some fairly simple Python code. So you'll notice that the red dot is where he's looking, and single letter variable names. And you'll notice that he keeps having to refer back to the function bodies. So his eyes are constantly having to refer back to what that f function's doing. He gets to G, and then he does something weird. I'm not 100% sure what happens here. But he's constantly referring back here. Now he goes back over here and sits there for a while. I think he got bored. So you could argue, well, he had to do that because the variable names were bad. Single letters, X, Y, F, G. Here's another video with better names. Add one twice and ask to do the same thing. He reads the code. Now he starts to execute it in his brain. And you notice that he keeps doing the same thing. He'll keep coming back to the function bodies. So that sort of says that even with better names, we're still not able to store that information. We don't trust the code. And that was one-line functions. Can you imagine what happens when you've got like hundreds of lines in a function? There's just no chance. A name's not going to be helpful. Now, I said that is readability the right thing that we should be aiming for? Maybe instead we should be aiming for comprehensibility. Isn't that what we do day to day? We don't read code, we comprehend code. I want to argue that instead of giving variables good names, let's try and give them good types. So this is a type signature. It says, I've taken X and I return an X. I take a string and I return a string. I take a int, I return an int. So what does this mean? Well, I want to try and aim for something called referential transparency in every function you write. This function isn't referentially transparent. This is a piece of code that I found at some point in my career, I'm not sure. But actually, it's PHP. I think I know where it came from. So referentially transparent means that I can take that function and replace it with its value. So if it returns true, I can replace that with true and nothing else would happen. I can't do that with this function because it's going to miss that global. It's not going to update the UI. Now this means that when I'm reading this function, I not only have to keep that function in my head, I have to keep the entire application in my head. I have to keep the entire application state in my head. And I have to then mutate it when I check if a user's logged in. Ridiculous. I don't know about you, but I can't keep like 2 functions in my head at any point in time, let alone an entire function. And this is why we have that don't disturb a programmer myth, because you've got an entire application in your head at any one time. Let's stop doing that, and instead let's just be able to keep values in our head and run that way. The next thing you want to aim for is consistency in your code base. Like with Ben's talk earlier, he hit problems with the word color. This happens all the time with my team. I'm the only Australian in a team of Americans. You can imagine how many times we get into arguments about the spelling of words. This is why I don't think English is such a good choice for programming languages, because it's so ambiguous. Different things mean different things to different people. You have context with words. Various words have different context depending on when you write it. Like with that example before, is logged in, it was missing that and can be grouped because sorry, go further back to the has children. It was missing the context that was in that programmer's mind at that point in time, which was the same, has children is the same thing as can be grouped. But I don't have that context. This is why you want to make sure that your functions are as short as possible, can be described by type, so that the context, there's more than one place that the context can live. And I hope with these new sets of axioms, we can stop writing tomorrow's legacy code today. Thank you.